Okay, so welcome everyone. In fact, welcome to lots and lots of people. I don't actually have any announcements this month, which is good. It means you don't get to hear me talk for long. So I'm going to hand straight over to Jim, who's going to tell us all about the Acorn Palo Alto Research Centre and what happened to ARX, the infamous ARX. Take it away, Jim.
So when I was asked to do this, it's been a while since this happened. So I went back to a bunch of presentations I had before and stuff, and I thought, I think I'll do a little bit of a chronology here. Partly, you need to know a little bit about where I came from to understand how the whole Acorn Research Center business happened. So I'm going to whip through some of my early education, get a sense for the kind of things that I work on. And then we'll spend most of the time, hopefully, on the Acorn stuff. So that's actually me. I forget how old I was then. But I started writing code in 1962. At the University of Waterloo, we didn't have much computing. We had an IBM 1620, but we later got an IBM 7040, and I worked every summer in the computing center, doing whatever the hell I wanted, which was a pretty nice gig. And then by 1965, so I was in the end of my third year, two fairly big things happened that had an impact. One was the University of Waterloo, where I went, is well known to have a very robust co-op program. It does huge numbers of students are able to get their education by doing the work-study kind of program. But they had a problem. What happens here is the students that are in school, towards the end of that, a whole bunch of companies come and they interview with them, and the companies say, okay, here's our first three, we got 3 openings, here's our first 3 choices. And the students go, I interview with these 5 companies, here's my preferences. And then the registrar's office by hand would attempt to do the best match it could of people to jobs. By 1965, they could no longer do it manually. The people didn't know their jobs until like the day before they were supposed to leave to go to a job. And they said, this isn't going to work anymore. And the head of the computing center convinced them that we could probably help them with that. And so I wrote a good old Fortran program to basically take in this data, the students' choices, the company's choices, and doing what's called a maximum matching algorithm on that bipartite graph. I only bring this up because you never know how these things are going to go. As far as I know, that program is, and it's probably been enhanced quite a bit, is still being used and is being used at most co-op schools throughout North America. I hate to think how many students it has impacted, but since you can't do better than the maximum matching algorithm, I can't feel badly if someone didn't get the job they want. Right? But the same thing, that same summer, I and 3 other undergraduates, based on a paper I wrote for a grad student seminar, we had gotten this IBM 7040, and its Fortran compiler was abysmally slow, and we ran lots of student jobs on the 1620, and the 7040 couldn't keep up. The IBM compiler was made for scientists. It spent a lot of time trying to optimize code and everything because you wanted it to run as fast as possible. It was a slow machine. It was like an 8 microsecond cycle time. Well, that just wasn't going to work. And so I wrote a little thing, said, here's what I would do to make a really fast Fortran compiler for the IBM 7040. And the head of the computing center called me into his office and said, you really think you can do this? Well, I knew a summer job when I heard one, so I said, sure. And he said, who would you need? And there were about 4 of us that programmed together a lot and hung out. And I said, we could do it in the summer probably. And we did. We actually started, the rest of the team started in April. I did this other program first, and then I jumped on starting at the beginning of May. And by August, we were showing it off at what was called an IBM share meeting in those days. There being no software industry, that's how you got things out. And it was blindingly fast, mainly because it compiled into memory and didn't try to optimize the code. What it did do was try to give as many errors as it could at both compile and runtime to the undergraduates who are using this as, to learn to program. Because with student programs, they've got errors. You want to get them out of run and get the errors out as fast as possible, because they run on small data. And when they finally run, who cares? It might take, 30 seconds to run or something like that. Anyway, that was hugely successful. And then the following year, it was ported to the IBM 360 systems. And that really put University of Waterloo on the map from the point of computer science. It sold so many IBM 360s to universities that about 1973 or 74, IBM gave Waterloo about $6 million to build the math and computer science building. I always like to say, what I got out of it was I have an alarm clock that they gave me that says we did this. So it wasn't, I didn't make a lot of money those days. Then here's the first time that hubris struck me. When we graduated, the same 4 people were talked into going to Bell Northern Research in Ottawa, and we were going to build the first full PL1 compiler in about 5 months. Those of you who knew that horrible programming language know that was ridiculous. Amazingly, we actually did get it done. I was still working on it when I went to grad school. It took 8 months. It ran on a CDC 3300. But as far as I know, it was one of the very first I don't think we left anything out. I learned a lot about language design by learning all the problems with PL1. And that turned out to be really valuable in grad school. Oh, and by the way, because we would work at night, we had to have the computer to ourselves, sleep in. I would get up in the afternoon. I went out to the Ottawa airport, and I got my pilot's license that summer. That was probably the biggest thing for me. Then I went to Carnegie Mellon, and because of this interest in compilers and languages, I got involved in trying to develop a language that was for people trying to use the computer in an interactive way, not just putting punch cards in and then seeing getting memory dumps and seeing, what the heck happened. If you're going to do it an interactive programming language, then you have to allow the program to change dynamically while it's running. You hit a breakpoint or something, and you go, oh, it's wrong. I should have initialized this variable to this. And can you restart it from there, and so on. There's a lot of interesting design problems, and we of course we did that as an interpreter. That was a team of about it was another 4 people, but these were all graduate students at Carnegie Mellon in Pittsburgh. And out of that grew the PhD thesis, where basically I said, so you pretty much have to do some kind of interpretation if you're going to have a fine-grained control over the program that's running and allow it to be changed. But interpretation is typically 10 plus times slower than compiled code. What are we going to do about that? And so I came up with a way of, if you will, compiling as a side effect of interpretation. And if nothing changed in the program, say the next time around a loop, then you'd just be running compiled code and things would go fast. That idea has gotten into, if you use Java, Python, JavaScript, they're all implemented that way these days. So it was a good thing to work on. But that also introduced me to language design, and that got to be useful in my next job. So I left. I was finished. I handed in my PhD in July of 1970, but I missed graduation that year. So my official graduation date is 1971, and I had lots of. It was those days. If you had a new PhD in computer science and you interviewed at N places, you got N offers because there were none, right? So I think I interviewed at 9 different places, universities and research labs, and I got 9 offers. Makes you feel good. And I'd hate to be trying to do that these days with what students are putting up with. But the best job in terms of a lot of very smart people was at a company called Berkeley Computer Corporation, which was basically one of the computer science programs at University of California at Berkeley. The people there had developed a time-sharing machine called the STS 940 that was used very widely within ARPA-supported research in the U.S. And these were smart people. So I went there. What I found out when I got there was they were running out of money. I was their last hired full-time employee, and 7 months later, the money was gone. Now what do you do? And it turned out we had been doing talking to people at the newly formed Xerox Palo Alto Research Centre, because the person they hired there to try and build up the computer science part of it was a man named Bob Taylor, who had been at ARPA and wrote the first check for the ARPANET, among other things. Literally, BCC shut its doors on a Friday, and the following Monday, so I was in the Berkeley area on the east side of the San Francisco Bay Area. I and a friend drove over to Palo Alto and signed on with the Xerox Palo Alto Research Center. I think we were numbers 7 and 8. At BCC, they had written this fairly large time-sharing system, all in we would call it a high-level language in those days, but it was a little bit like BCPL. And I ended up, within a month of being there, I was in charge of all the file system part of the operating system. And I was dismayed because if you're going to build a time-sharing system, you have to be very careful about security. And so whenever someone is making an operating system call, you don't want them to trick you and give you an address that would allow you to do something in the wrong part of memory, all those sorts of things, right? And I noticed that many of the parts of the file system, especially ones where you're trying to get information about, the length of a file or something like that, the program would have a whole bunch of if statements checking all the parameters that had been sent to you with the procedure call, and to make sure they couldn't trick you. And then you would do a one-liner that returned the values that the thing wanted. I said, this is ridiculous. That's no way to build systems. We have to learn to do this better. And so that prompted the beginning of this systems programming language called Mesa, which had strong types, was the first thing to have separate interfaces from implementation. So you could build your part of the system and call other parts, only knowing what their interfaces was while they were being developed. But you could get compiles done and everything. That took a fair number of years to do that, about 4 or 5 years total to get it. And then we basically used it for a lot of stuff. As well, so after that, we were very interested. This was before relational databases existed, and everybody was trying to figure out what's the right basis for a database system. And we made the mistake of thinking that atomic transactions for file system was a good way to go. We actually tried it. It didn't work very well. What everybody's gone to in that world are log-based systems, of course, and that works very well. But it was there was a lot of smart people there. at least, how many? At least 2 or 3, actually 4 people who ultimately got Turing awards, and we knew that by looking at, I don't know if we knew Moore's law by that name, but we could see what was going on, and we decided that what we should do is look out 10 years, build ourselves machines that would be what you could afford in 10 years, and program them so that when the time came, you were ready to go to product and you had something that you actually knew would work. And out of that came the Alto. There's a picture on the right there that had a keyboard and mouse, a bitmap display. It was just 1 bit per pixel. Removable disk drive. I think those disk drives, I think each individual one held 2.5 megabytes, but my memory's a little unclear on that. We got the first laser printing working, and the what was called the research Ethernet. Eventually, it was the 3 megabit per second Ethernet got invented. That was obviously very successful. That was one of the Turing Awards. And we built this software with a windowing system. The first, what you see is what you get document editor. And in fact, the person who did that, Charles Simoni, then went on to Microsoft and turned it into Microsoft Word and Office. He made a lot of money doing that. Laser printing software. The follow-on to that ended up to being Adobe System doing PostScript and so on. An email system, a distributed email system, computer graphics, file servers, all the things that you know today, we were building in a short period of time there. And so we all had in our offices our own personal computer that looked like that picture on the right. And out of that grew, often by people moving, things like the Apple Macintosh, the Ethernet, as I've mentioned, Sun Microsystems workstations and servers, Microsoft Word, Adobe PostScript, PDF, Photoshop. We had one of the first network games there. So it was a pretty heady time. We did things pretty quickly, and once everybody had their own computer, you could program, fast. And during that time, one of the things I was able to do was spend about 9 months at Cambridge University when Roger Needham had just taken over as the head of the computing laboratory. That turned out to be propitious for me. So starting in about the summer of 1983 to about January of 1984, those of us who were at PARC were getting fed up with Xerox not knowing how to turn this stuff into products, not believing it. They didn't know what they had. And we were just very frustrated by all of this. And there's been a lot of books written about that, of course. But people started leaving from about the summer of 1983 until January 1984. Most of the researchers, and certainly the strongest ones, left and went to places like Apple, Sun, Digital Equipment, Adobe Systems, Microsoft, etc. And I was in the process of doing exactly that in January of 1984. And in fact, I was going to go to Digital Equipment, where Bob Taylor, who ran the computer science lab at PARC, had gone. And basically people were going there, and it became I think it was called the Systems Research Lab in Palo Alto for Digital Equipment. And I had said I think it was on a Friday, I told Bob Taylor, okay, I'll accept the offer and I'll come. On Saturday morning, Herman Hauser showed up. He had flown from Japan because he heard that I was, what we used to say, loose in the saddle, like I was changing. And he spent all weekend with me and with Carl Deller, who was working for Hewlett Packard at that time in the Bay Area after he graduated from Cambridge, and had this crazy idea that he wanted to start he wanted to get access to the software research that had been done in, I don't know if it was called Silicon Valley then, but basically in the Palo Alto area. And he talked me and Carl Deller into doing this. And he said, you know, we can build a really good operating system. And of course, it was because he told me that they were doing the ARM, and I certainly knew about hardware, and I was impressed that they were going to do a RISC machine. And I thought, well, this will be a learning experience. And so I actually went on Monday of the next week. I had to go back to my ex-boss, Bob Taylor, and say, gee, I'm really sorry. I'm not going to come to Digital Equipment. I'm going to go off and do this other crazy thing. And he wished me luck, and off I went and started trying to recruit. We had an office, no desks or anything like that. I wrote for the first month, I wrote all my offer letters in longhand. I think I rented 2 chairs and a desk so that I could actually interview people. And we got going. I'll say on the next slide how we got people from Cambridge who had already moved to California. We got some people from Cambridge who hadn't already moved to California. We got some other people who were already in California that I knew because there were so many things in flux with people moving around. It was a good time to try and build a team. So we started doing that, and I would make occasional trips to the UK, like but once a quarter. Then a new person came to be the managing director for Acorn, Brian Long, who sadly passed away last year. And the next thing I knew, I was in his office, and he was saying, "I want you to run R&D in both places." And I said, "Well, they're 8 time zones apart." And he said, well, the only thing you have to do is you have to be at the monthly staff meeting. And I don't know why, I don't know how I talked myself into it, but I did that. And so for basically about 2 years, I commuted monthly between California and Cambridge. I was very good at handling jet lag. And the goal was we were going to do this new operating system. It didn't have a name at the time. An operating system that used what we knew from our work at PARC and everything, that would eventually run on the ARM. Of course, we did all our development on BBC Micros. And because I wasn't going to be in Cambridge all the time, I was there 10 to 14 days a month. Steve Ferber, a great guy, obviously. Steve would kind of manage things when I was in California, and then I'd show up, and he and I would meet and say, "How are things going?" and so on, and then I would go to the staff meeting and so on, and try to do my best to help people there, especially when they had problems with getting resources. It's still amazing to me that ARM was done. All our simulations were done locally on a VAX 750, and when we wanted to do real big simulations, we had to go to I think it was Munich, it might have been Vienna, where they had a 780 we could rent time on. But and it was like what 15 or 20 people who did this processor. I consider that just amazing. I can't take any credit. I mean, I kibitzed on some of the instruction design and so on, but obviously it was Steve Ferber and Sophie Wilson and the team who did all of that. Okay, so you've got all that background. This wasn't my first operating system that I was going to be doing, and the standard stuff about Windows and everything we sort of knew, but I'd had some ideas I'd been working on for a while for building a more distributed kind of operating system to make it easy for programmers to build collaborative collaborative software for system to allow groups to work together and interact in real time on each other's screens and so on. I was already committed to, we needed a high-level programming language. And we were able to get Mick Jordan, who had come from Cambridge, actually to PARC, and could do Modula 2, which was the closest thing to Mesa that we would have. So we were writing and maintaining a compiler. The operating system, we knew it had to have multiple processes, but you needed to have protection. This was not a single system that occasionally would send files over the network. It was meant to be a system where it was using the network with other machines a lot. Herman Hauser was very excited about what was just coming out those days. These were write once, read many CDs, and they had a lot of storage, and he wanted us to build a file system that would support that. That was definitely a brand new thing. Another brand new thing, well, pretty new, was I had this idea about how we could do a Windows system that would allow people to interact in real time from their separate machines, no matter where they were. And I knew we needed a reasonable document editor. We weren't after something with fancy fonts and everything, but we had to have something that would make it easy to do stuff. And in fact, we had a representation for those things that would allow you to easily package up a document in while it was being edited and have it go to someone else's machine, and they could then they could be modifying it and so on. John Gibbons, also, who had come from Cambridge, was probably one of the chief people on that. And Herman said, look, I know this is a lot of work, but you got about 3 years. It's going to take about 3 years to get the ARM done and everything. And so those were that was kind of the goal of what we wanted to do. And the team wasn't too large. It was based in an office tower in Palo Alto. I might have these numbers wrong. There might have been 4 Cambridge expats. There were 4 Acorn developers. I count Joe Dunn as one of them. 3 US developers, a couple of admin staff, and me. The main collaborative part of that was Carl Deller led the file system, and 2 people from Acorn UK. They would come very frequently, and they all worked together to try and build that file system for these write once, run anywhere. Write once, read many CDs. That's a lot of stuff. Here's kind of what worked. In about 2 years, we had a working Windows system. It was somewhat slow, but that didn't surprise me. I knew that we would easily be able to speed it up by a factor of 3 or 4 once we had something working. An initial file system for these write once, run read many CDs. The simple document editor that ran in any of the windows, and all the basic OS functionality for multiple processes in what I would call the traditional way. That is, you expected applications to make calls down into the operating system for it to do things for them, and then return values or cause whatever action it was supposed to be. And so security at that boundary matters a lot, especially since you're going to have these things highly networked. I think we did a good job on those things, but as I say, when we first demonstrated it in Cambridge, lots of windows and things, but it was not as fast as I would have liked. You can't do interactive things and be too slow. But there were things that didn't work, and we were really trying to do too many new things in a short time span. I would say that I should have known that the time that we would have would actually be shorter than we were told. And as it turned out, I think it was late 1985 when it wasn't just Acorn, but here in the United States as well, it was called the Christmas that didn't happen in the computer industry. People were building all kinds of things to sell for home computing aficionados, and in the United States, I forget, they plowed under some fair number of things, and Acorn had the same problem. Now all of a sudden we've got a big problem with money and all of that stuff. And so with 2020 hindsight, we should have done a much simpler thing, and maybe even just taken something. I was worried that Unix, the Unix that I knew in those days, because it was clearly around, I was worried it was going to be too big. And I think we would have been better to take Unix, or was Linux around then? No, it was a little early. And basically strip it down. That would have probably been a better thing to do. We would have still done a Windows system, but not one with this collaborative feature built into it. And I would have changed the CD-ROM thing to be a project that could be added in later and do a file system for the normal kind of hard disk. But I would think one of the biggest things that I didn't understand was that was the cultural issues. Creating an outpost in California that caused problems. Later in my career, especially at Sun Microsystems, I ran research for them. I learned that even when remote working started to become a standard thing at Sun, which was like around 2001, 2002, if you were going to have a distributed team, given that normal primate behavior, if I hired someone who was not local, I made them come to Sun for at least a month and a half, so they became part of the team before they were allowed to go back home and work remotely. And even then, they had to come at least once a quarter. So we had lots of personal, intense interaction. And without that, it doesn't work. We at one point at Sun, for example, we did hire someone who was far away, and they came for like a week, but they couldn't stay. I forget why. They couldn't stay for a month or two, and they never really became well integrated with the team. And that sort of happened here. I would say the best integration was Carl Deller and the people working on the file system, because they came frequently and spent a fair amount of time together. That really worked, probably the best. But there are cultural differences, and I don't mean, yes, there's the UK versus California, but there are cultural differences. There were cultural differences about how Acorn UK worked. It's really a good product company, and has very smart people. And I had come from, as I said, from this research background where our time scales were quite a bit longer, and so that cultural difference was also a big issue. And I worked hard at, and I would travel every month all the way to England, and I worked hard to try and make it work. But we really should have done something. When Herman first proposed this, we should have decided that we should take a 3 or 4 month period and mix the teams and get it so that it felt like one team. I think that would work. That would have had a better chance of working, and we would have built a somewhat different thing, of course. So that's kind of the overview of what went on. And as you know, partly because of these cultural differences, people in Fulbourn, where Acorn was, were getting nervous, and so the hardware was coming along. So there was the Arthur operating system that was built, and then RISC OS. RISC OS. I'm trying to remember. No, I'm forgetting his name. William Stoy. Not very, very smart guy. And one of the discussions we had there was, I said that ARX was a very traditional call down into the operating system. And if you have multiple processes running, they communicate through the operating system. And there was another school of thought around at that time for small computers that making it so you could do up calls out of the operating system to the application to say it's your turn to run and things like that. That was it made writing applications somewhat easier, but of course the problem there that I immediately said was, well, but what if the thing never comes back? How do you make things continue to run other than normal time slicing and stuff like that? And we were already very far along with the more traditional thing. And I think RISC OS kept that architecture. But I think this is a good point to open it for questions. I can't see the chat thing on my screen, so I think Brian's going to kind of, if there are questions, Brian's going to act as moderator here and read the questions to me.
I can try and read them out. Of course, probably if you stop sharing, you'll probably see the chat. But in fact, maybe if you stop sharing, then we can see you answering.
Okay, let's stop sharing. I'll do it right here. We go.
So I don't know where to start. Just start with one thing that was just, well, the first one right at the end there is there anything left of ARX? Because there was a couple of questions in the chat about, is the source code still around? Are there screenshots of it running or anything?
I certainly wouldn't. It would have been unethical for me to take anything with me. So I don't. And I turned back in all my documentation and everything. So I doubt there's anything left of it except what's in people's heads.
That does seem a shame. Right. Right,
yeah, one of the things that I guess I didn't mention this. I really felt let me back up just a little bit. Eventually, Acorn really had big money problems, and it needed to find someone to buy them. And Herman, bless him, he worked hard on that, and ultimately got Olivetti to invest in Acorn. As part of that deal, what do you do with ARC? Because by that time it was clear that it should be probably RISC OS that should be running on that, and then later, Unix got ported to the Archimedes, and so it was decided. I think Herman was made vice president or managing director of research for Olivetti, which I always viewed as kind of penance for them investing. And so we went to work for Olivetti. Then I started doing trips to Italy. It didn't take long for me to figure out, again, Olivetti is a very different company, even than Acorn. And ultimately, the research group was put under a product team. That's the kiss of death for research. It just is not going to work. As soon as the budget time comes and there's a squeeze, you look around, what are you going to squeeze out? Well, that research is not making us any money, so that'll go. And we had this operating system that had a lot of functionality, and I would consider what I would call a really good first draft, good working first draft. we should have gone to, we were not bold enough. We should have gone to places, talk to Bill Gates, for example. I mean, this had most of what NT had 8 or 10 years ahead of NT. Give that team another 3 or 4 years with ARX, and they would have had something like NT earlier than they ultimately did. But I think that was a failure of courage, maybe, to go and do that. I did suggest that to El Sereno Pio at Olivetti, but it didn't really fly. And I kind of wish we had given that a better try. But the result is there really is nothing left of unless someone else like Sophie has saved anything. I kind of doubt that.
Basically, when it was, so the team was just basically just discarded. Effectively, the whole team just split up.
Well,
that was gone.
There's an interesting little story about. So I could see what was happening, and I forget how this happened, but Herman created another lab in Olivetti Research, which was somewhat more people from PARC, being run by a guy named Jim Donahue, who I think went to the University of Toronto. And the two of them went in, the lab I ran and they were going into this one building in the Palo Alto area. And this was when we got moved into the product organization. And I thought, this is not going to work. And at that point, I started looking around for other opportunities. And a good friend, Eric Schmidt, who later ran Google, was VP of software development at Sun Microsystems. And when he heard that I was available, then they made me an offer and I went to work there, doing operating system stuff again. This was going to be, I won't go into that. That's a whole nother big story. But then sure enough, Olivetti showed up on a Wednesday. Someone from Olivetti showed up on a Wednesday at the Olivetti Research Centers and basically said, clear out your offices. As of Friday, none of you have jobs. Well, these people felt pretty awful. And I went to a guy named Wayne Rosing, who I'm still good friends with, who ultimately became VP of engineering for Google, and told him there's this team, these two teams of very good people, and all of it is just cut them off at the knees. And he came up with a great suggestion. He said, email them and tell them that if they come to a job fair here on Monday with their resume, we will give them all a month-long consulting contract, and they'll have a salary for a month. All they have to do is bring the resume and come to the job fair. I think of the roughly 25 people, I think we ended up getting about 18 of them to come to Sun. So that was a very smart thing to do, and the people were smart and very talented. And I think getting cut off at the knees like that, and then finding out no, there's somebody else who's doing well and wants you, that helped enormously. So we got a good team out of that.
Well, I think slightly just diverging from the things in the chat, but the question that was actually posted online the other day, one time asked me to ask, but it links to what you were saying, was whether any of the work you did on ARX relates to the stuff you end up doing on Spring at Sun, whether there's a similar kind of
No, not really. So the Spring operating system, there's, if you can see behind me on the wall, that's the CD for it. So I do have that. At that time, there were two Unixes in the world that were commercial, the AT&T Unix and BSD. And just a second, I'm having a senior moment. Bill Joy and Sun were doing a deal with AT&T, and what they wanted to do was merge the two Unixes so there'd be one, and that was to AT&T's benefit because Sun was eating their lunch, and it had three phases to it. The first phase was getting things lined up. The second phase was actually producing the unified Unix, and the third phase was, and this was Bill Joy's idea, we're going to redo Unix in an object-oriented fashion. That was my job. And what grew out of that was a thing called the Spring operating system, which was a distributed operating system. And the only part of that that really survived out in the world was that the mechanisms for doing remote procedure call between Unixes, basically, and that got put into some standards at some place and gets used. But we had the same issue. We had Unix, and we had really good people doing that, and Sun was being very successful, taking a brand new operating system and that would look like Unix but wasn't Unix, and making it happen. That was just not going to work. Again, what we should have done was not be in research. We should have been in the actual product group, and we ultimately did move there. Most of my team, what ended up happening with that was that all of a sudden around 96, 97, Java became a thing. And I had worked on Java with James Gosling in the early days of them doing that. By this time I was running, I was still just running the Spring operating system work. And Bill Joy came and said, "You've got this great team. We know we're not going to ever get Spring in to replace Unix. We need help over in the Java land." And my whole team, including me, we all went in and became part of JavaSoft, and did a lot of, I became forget my title, VP of Technology and Architecture. And James was, James Gosling, the real inventor of Java, and I, we're still good friends. We're both Canadians. Our wives are both named Judy. We both worked in programming language design. So we made a reasonably good team. I was supposed to deal with things down and in, and because James was getting constantly pulled up and out to go to conferences and things like that. So we just dropped Spring, and we took a lot of those ideas and we put them into various parts of, like, Java running on the bare metal, the Java computer, network computer. We made that happen in only about 6 months, I think, hardware and software. So that's what happened with Spring. So I had 2 operating systems that never came to fruition. That was the last time I worked on operating systems.
Right. I'm going to go right back to the start of the chat now. So we've completely changed topics. So the first question was about the What4 compiler. It says, was that the compiler that later became Whatcom, and therefore Whatcom C later on as well?
What happened with that was that, the What4 compiler did very well. On the 360, they called it What5, What FIV, a little punny. And the group that, the 4 of us that did the What4 compiler, they wanted us to do that the following summer when we graduated. Why just stay here and port it to a 360? Well, that's boring. And instead we went off to try and do a full PL1 compiler. And we were young, you know. But ultimately, What5, as it ended up getting called, what really got all around on the 360s, was hugely successful. The 2 guys who did that port got the Grace Murray Hopper Award for it, which was really good. And there was starting to be a software industry around the late 70s, and So the head of the computing lab at Waterloo, Wes Graham, uh, uh, basically said, we could start a company doing this, and they did, and they spun off from the University of Waterloo um, a, a group of people that became Whatcom, and they did the Fortran compiler, and then they did there was what COBOL, right? That whole set of things, and that was pretty successful. But I was never involved with that company, except I went to visit a couple times and talked to them because they were friends. But I was not involved with the company.
Okay, so the next question is still on compilers. Sam, what's the Modular 2 compiler you're using for ARX? Was it written from scratch for that, or did you just retarget an existing Modular 2 compiler?
It wasn't written from scratch. When I was on sabbatical at Cambridge, Mick Jordan started working on the Modular 2 compiler there. And I think on an earlier slide, I mentioned that Klaus Wirth had come to PARC 2 times for a sabbatical, and he was very interested in Mesa. We had lots of great discussions. And then he would go back to ETH and in Zurich, and Modular all of a sudden changed into Modular 2 with interfaces and things like that. So that was a nice bit of technology transfer. I think the right way. People take the idea and go and re-implement it somewhere else. And Mick Jordan was working on that when he was at Cambridge, and I encouraged that. And then later he came to the United States, and we were able to grab him, and so he already knew the compiler, and it was more of a retargeting.
Remember when we had Paul Fellows talk, he said that because it was kind of not that a mature compiler, it wasn't producing great efficient code particularly. Did you have to fight with that a bit as well then?
Since we never got to with ARX, we never got to do what I think of as stop developing things for a while, start measuring everything and find out where's the time going, what are the bottlenecks, and so on. I really don't have a good answer for that. It wouldn't surprise me that the code wasn't the most optimal in the world, but it was the bits that I looked at seemed okay, but it wasn't doing huge optimizations.
Okay, so next one was me. So yeah, the CD file system, would that have had basically effectively version history and control by just permanently writing each new version as a new file, and you would have been able to go backwards and forwards?
I'm trying to remember as much as I can about that file system. Is basically you are driven to make it a sort of log-based file system, since you can add new things on, right, all the time, and so it's really easy to get versions out of that.
But it wasn't a specific target.
And indeed, I mean, most email systems these days play the same game. They use an underlying log. That way you can just, if everything goes to hell in a handbasket, you can always just replay the log and get the email back with fast access to it.
Okay, next one is, what network technology were you envisaging for ARX? Was it going to be Ethernet or Ethernet or something else?
Both, but it had to work with Ethernet, but we expected that it would probably work with something like Ethernet. In those days, there were all kinds of candidates out there in the world still. Ethernet was in the process of starting to get standardized, but remember, there's the Cambridge ring, there were the IBM token rings, and I think I've forgotten one other, but we knew that there would be more networking things coming along. It had to work with Ethernet, but it had to also scale so that it would work with faster networks.
Presumably then it would also work across wide area networks as well then, if you could have essentially used it for your team between Cambridge and California, couldn't you?
Yeah, although in those days, trying to get any high-speed lines that distance would have been impossible, I think.
But it would have been,
You know,
would have been something for the future again. It's like you're saying, aiming for things that will in 10 years' time. All right, next question. It says on slide 7, was that working on the ARM? I don't know what slide 7 was.
The list of all the different components, the file system, the window manager.
Oh yeah, a list of all the things that it could do, the window manager. Was that all already running on the ARM then? Presumably you were actually.
I believe it did. I believe it did. Joe, do you remember when we did that demo at Fullborn of ARX?
Yeah. It was running on the ARM.
Yeah. Okay.
Yeah. No, we that was the one where we went over for 3 weeks, right, and put it together. That one.
Yeah. That's right. Thank you.
Yep.
No, I've just noticed that Brian Coburn answered about the Modular 2 compiler when I've scrolled down. Welcome, Brian. Apparently it says the Modular 2 compiler was ported from the ETH compiler, and Mick worked on getting it going on the ARM.
Yeah.
Oh yes, again. So I'm going my questions here. That was when I was posting ones in. Yeah, did you ever think of maybe just moving to the UK and running the team there, rather than being in California? Do you think that would have helped? Because then you'd have all been together. Well, I think you answered that in the talk. You said yes, but yeah.
Well, I wouldn't have been able to get the whole team to move to Cambridge permanently. That's for sure. A lot of them had done their work to get to the United States, and they didn't, they had green cards and things like that. In fact, so did I. I still have my Canadian passport. I now have both Canadian and American. Given the current political climate here, it's really nice to have.
Okay. The next 3 questions I think you all asked, because they all were, what was left of ARX? Does any of the code survive? And does anything survive, even the documentation? So I think you've already answered that by saying no.
I certainly don't have any, because I would not have kept any. That would not have been ethical. I made sure I got rid of everything that was Acorn private before I moved over to Sun.
Okay, next one. Jonathan said, did you have experience working with the PDP-11? Because it's always struck me that the ARM is like a 32-bit PDP-11.
I don't think the ARM's like a 32-bit PDP-11 at all. It really is a RISC machine. I still love that the architecture. It's hard to recognize these days, given everything that ARM Limited has had to do to do all to make themselves the power horse that they are in the world. No, it was a true RISC machine. It was about as simple as it could possibly be, because otherwise we wouldn't have been able to implement it. So and in those days you spent a lot of time worrying about how compact code could be as well, and so some of the things in the early ARM, I don't even know if they exist still, where you could do an if then else and just fall through rather than having an actual branch and so on. We did a number of things like that, but I don't think of it like a 32-bit. PDP-11 is a peculiar machine. I mean,
it's more like a 32-bit 6502, I think.
Well, I think that was what they aimed at, wasn't it? That was their kind of thinking when they were doing it, was they wanted a 32-bit 6502.
Yeah. The real reason for that, and it was Sophie who pointed it out to me, was they had actually, and Joe will know more about this, Acorn wanted to go to faster systems, but when you tried the commercial, like the 6820 and things like that, they were 32-bit, but the memory path was still only 16-bit. And memory bandwidth is what matters. So that was what drove them to actually look at doing their own 32-bit processor. And the RISC idea had, I forget when that came out, but certainly the early 80s. I was at conferences in Palo Alto where Hennessy and Patterson were talking about RISC. And it looked like that was going to be that was going to change the world. It really did. Everything's a RISC machine these days. When you look inside an Intel x86, that's what's there, right?
Right, I need to go these questions quicker because I think they're coming in faster than I'm asking them. Do you think
gee.
ARX should have had a bigger team? Would that have helped, or would that have been a hindrance, do you think? Because
Maybe a few more people, but the biggest issue was the split of time and culture.
okay, next one's interesting. Can you remember what the windowing system looked like? How different or similar to other graphical user interfaces was it? Was it 3 buttons like RISC OS? And in fact, did RISC OS take any of the UI from ARX? Or?
Not that I have no idea. I don't know enough about that.
Did it have an icon bar at the bottom for a dock, which also goes into the next question? It said, who came up with the icon bar first? Apple, Xerox, or Acorn?
I doubt it was us because I didn't like that idea. There was a lot of stuff on the Mac that I didn't like at first because I said it's a little too simple. And when you scale this up and have bigger screens, it's going to be a hassle. And I still swear occasionally when I'm doing something on the screen and I have to go way up to the upper left-hand corner in order to do something because I don't have the keyboard shortcut in my head at the moment. But I'm not going to argue with success.
So did ARX use pop-up menus like RISC OS, or was it a menu bar?
Oh, I think it had pop-up menus.
Yeah.
I'm pretty sure we would have used pop-up menus. Honestly, I don't know. I don't remember.
This is where we need screenshots, don't we? But because people weren't carrying around cameras in their pockets all the time like they are these days. So.
Yes, they didn't exist.
Okay, what's the next one? Can you tell us a bit more about support for distributed applications and work? Look what it looked like. And did you mean that your editor could allow 2 people to make simultaneous edits?
Yeah, let me think about that for a moment. That was one. I take the blame for pushing on that. We had started when I was at PARC, and we had on the Alto a pretty reasonable Windows system. There were lots of times when it would have been very nice for say 2 or 3 of us to be able to look at the same document and be able to make changes to it and talk about it with real-time communication. And one of the questions there is who's in charge, right? Whose mouse is actually controlling things as opposed to watching, and how do you pass control back and forth so that it feels natural, like 2 people standing at a blackboard working together. That was kind of the model I had. So you could step up and say, well, I think this, and it had to be really easy to do that. So that meant that at least at that low level of interaction with the Windows system, that had to be done in this distributed fashion. I'm not sure that answered the question.
Okay, the next one says, why modular 2? I think you asked that in the talk when you said because it was most like MISO.
Yeah, but right. In the early, I had come from this background where things like we were using BCPL to start with at PARC. When we first started at PARC, of course, we didn't have our own we didn't have Altos, we didn't have anything, but we bought Data General Novas. We got BCPL. I don't know if we had to port it to the Data General Nova or not, but we could start building systems with that. I already knew from my experience at Berkeley Computer Corporation that we needed to move up into higher levels of abstraction in the languages in order to make programmers more productive. And strong typing and interfaces separate from implementation were two of those the ideas that were to push that. And so when we went to created the Acorn Research Center in Palo Alto to do this, I looked around and what was available outside, and Modula 2 was it, basically, that had a lot of that same those same features. We were unlikely to use Smalltalk, which also came out of PARC.
I like the next one's not a question. It just says, tell us about the demo. Which I guess is, yes, the demo when you did the kind of showdown between ARX and Arthur. how did
Was
it
it
go
a showdown or
from your
just we did a demo and they did a demo? Was it a
yes.
showdown?
I think showdown is just how it's become to be known as a bit of a joke.
Yeah.
Yeah, how did it go from your point of view?
Well, I like the fact that you could have multiple windows up and they were working, and I had to apologize for the speed. It wasn't blindingly, I mean, it wasn't glacially slow, but it wasn't snappy.
I think part of the sorry, it's Joe. I think part of the reason that sort of resonates over the decades is that Sophie and the team in England were super into speed. Like having things go fast was sort of number one. And so that concern, I think, overshadowed a lot of other stuff because they just everything about the machines before the BBC machine and the BBC machine were designed to go like fast,
and take as little memory as possible
and be tiny. Yeah, and that was in the culture. And so we were showing this thing which was big and slow, but it had a lot of curious functionality in it. It had all this new stuff in it.
Do you think you were building a workstation and they wanted a personal computer? Kind of almost. It was.
That's actually a good way of putting it. Yeah,
yeah, kind of. Although those concepts didn't exist, right? It was.
Yeah.
I mean,
well, Sun was around.
Was it though?
The workstation idea existed. Sun was around, and
yeah, I guess
it was just Sun started in what was it, 83 or 82, somewhere like that.
Okay.
Where Andy Bechtolsheim. One of the things that happened. This is a little bit of history. When people learned about the Alto that PARC had built, most of the research in the United States at that time was being supported by ARPA, the Advanced Research Projects Agency of the Department of Defense. All the people out at the universities, can we get Altos? So we actually hired somebody from he was from the UK, come to think of it. Nothing to do with Acorn. And we started building Altos and selling them to, not for any profit, but selling them to universities, along with laser printers. And because everybody wanted those things, right? Everybody was trying to make documents in those days, and everybody wanted an Alto. And Andy Bechtolsheim at Stanford University in about 82 looked around and said, the commercial microprocessors and so on, they're all getting to where you could actually build a workstation like the Alto out of commercially available parts, not something special like the Alto was. And he built a prototype, and then the ARPA researchers wanted to start buying that, and that's how Sun got started. And Sun, you probably know, actually stands for Stanford University Network.
Just back on the
So-
just back on the demo, if you don't mind me saying, just
Yeah.
not technical details, but it was a very high stakes demo. I mean, I remember it as being very high stakes. You know, we were there for 2 or 3 weeks setting it up. I think we'd actually decided to call it a beta or something, maybe, and we'd set a date, and we did the demo on the date to a bunch of executives, and it was super high stakes. And I remember Brian Long, you know, even after all these decades, I remember Brian Long, who was the CEO, I guess, at that time, saying like, "Well, you set a date and you showed us the demo, and it's, you know, good, and congratulations." It's like it was one of those. Yeah, it's just very high stakes.
Yeah. Some people, I remember our manufacturing guy who was Irish, was his name? Oh, rats. Anyway, he had not seen, yeah, right. He had not seen Windows systems like this. He said when he saw multiple windows on the screen and being moved around and things running here while they're running there, he said, it's like magic. And I thought, well, we impressed him a little bit anyway.
Yeah.
But Sophie was sitting there going, it's too slow.
Right. Yeah. Too slow, and I can do that in 1/10 the size. Like I don't.
Yeah,
need
I
all
can
that
do it in
stuff.
BASIC. Yeah.
Yeah. Yeah.
Right, that's a question still ahead of me. What ARM-based hardware were you using to develop on? Was it like you start with second processors and then dev boards and then the A500?
I don't remember. Most of the development, the early development, we would write stuff on we all had BBC micros. We had one Macintosh at the Acorn Research Centre, so we could actually do some documents and have a little printer. It wasn't even a laser printer, I don't think. In those days, it was a line printer because the PostScript hadn't come out yet.
Got a related question to that, actually.
Oh, God.
Yeah.
Question
Brian
here
says
in-
second
question here in the pub.
processors.
Oh,
Yeah.
better turn that round.
Just a related question to that one. It sounds from what we've all heard over the years is that it was quite memory hungry, the system, and I wondered if there'd been a change in specification, maybe because the machines that shipped, lowest end machine was only 512K, and I wondered if that was something that wasn't really anticipated when work on the OS began.
I'm sorry, most of that didn't come through very clearly, so I didn't hear the question.
Okay. The question was, did the specification change? Because when they first shipped the Archimedes, they shipped it with 512K. And I wonder if when you'd started, were you expecting that they were shipping 4 megabyte machines and therefore you really hadn't expected to hit 512K?
No, we didn't. No, I don't think we expected 4 megabyte machines. No. We knew that it was that things had to fit into I guess what today was a smallish memory, but 512K is pretty big. You know, the Alto was only a 64K machine.
Mm-hmm.
And then we made something that we called wide-bodied Altos that were 256K. And I did that atomic file system on one of those, basically. I would have thought 512K was ample in those days. Nowadays, my watch has, I don't know, it's not quite a gig, but.
Right, there's some various comments from people. I'll skip past some of those. Oh, did the work on ARX have any influence on the creation or the adding of the swap instruction onto the ARM3? Because it allowed atomic operations.
There's no way I would have any knowledge of that.
Probably came along a bit later, didn't it? Oh, in fact, there's Brian Coburn answering. Needed for RISC. Okay.
Can I ask a question, please? I'm building this picture where you're talking about when you did the demo to show the work the research group was doing. and presumably there was a similar demo of the RISC OS. What did the research team think of RISC OS? Could they see a pragmatic point of view that this was going to have to ship?
Sure.
Basically? And was
Yeah.
that were there heated conversations about it, or was it just simply resigned to the fact that one project was sort of more shippable and faster than the other one? Or
Well, by that time, all of this stuff with Olivetti was going on as well, so everything was in a state of flux. I certainly had with William Stoy and with Sophie. I had lots of discussions about aspects of RISC OS, but they weren't heated. They were technical discussions.
Yeah, I would say compared to, let's call them strategic conversations I've had in Silicon Valley since then, they were extremely mellow.
Yeah, yeah.
Given the stakes that we were all dealing with, they were quite polite. I mean, yeah.
and you were
part of
given,
it, I mean, part of the I mean, this is my memory now, but part of the sort of vibe that was going on at that time was Brian Long was the person, I think, that had to make the decision, right? Is that right? That's what I kind of remember, or he had a big influence on the decision. And
he was the managing director. He would be the ultimate, yeah.
Yeah, and he was non-technical, right? And so he came, I mean, famously, he came from a tractor company, right? So his idea of both the technology and the timeframes was very different. I remember, I guess the only heated conversation I remember was actually with you, Jim, and me and Brian Long in a restaurant in San Francisco, where of course, me being me at that time, I was trying to make him make a decision immediately, and that's the only heated one I remember. But there was this kind of thing where you had two teams working away, plus there was also the option of Unix in some weird way, and Brian was listening to all these conversations that, smart people talking about things he didn't understand and wasn't making decisions. I mean, that's kind of my memory of it.
and I'm also, am I right in assuming that it also wasn't necessarily a single decision on one day, because the original ship, Arthur was shipped first, still with the intent that ARX would supersede it. Is that right?
Well,
Wow.
But again, you have to look at this against the background of everything that was going on with Olivetti.
Okay.
Because that was and trying to get an investor. I don't know that Olivetti had signed up yet, but I think so, because I was certainly in staff meetings in Cambridge where Olivetti people were in the room with us and Brian Long. So it was right during that period that all of this was going on, and then the surprise to me was that Herman Hauser became VP or director of research for Olivetti, and ARC was moved over there. That was obvious, and I was not involved in that decision, except informed of it, if you will. So there was all that stuff going on in the background as well at the time. That pretty much dominated things.
Thank you. Thanks for that.
I think replies from Brian Coburn in the chat, I think, for the earlier questions, that yes, the original development was on ARM second processors and then A500s. And his memory is that the A500 was going to start with 1 meg. And the only reason they shipped a 512K one was because they could with Arthur. So that's really normal.
Yeah.
You can't make a machine that cheap, you will. Yeah.
Yes. Yeah.
Right, well, I actually caught up with the chat now. So any other questions anyone wants to throw in? Well, I'm temporarily going to mute this up there,
and I'm getting close to timing out. I have house guests arriving from Northern California who are waiting at the airport at the moment. Let's see if they've.
Right, so if anyone does have a question, get it in quick.
Yeah.
Yeah, just a quickie. Why did you say PL1 was horrible?
Oh, where shall I start?
Ha!
I knew you
I
would ask this,
remember,
John.
I remember one thing. The first thing that when the team of four started doing that, the first thing to do was get the language manual and learn every little detail. There, PL1 tried to be too general in a number of ways. And here's one I remember. Depending upon the precision of numbers, because you could have these fixed point numbers as well as floating point numbers. And there were rules about what happened if you multiplied two fixed point numbers, one with 2 digits of precision, one with 3 digits of precision, etc., how all of that was supposed to work. And then you assign it. So you did that multiplication and you assign it to a variable that has a different kind of precision. There were reasons why you could not actually compile code for that and had to jump into a sort of interpretive mode at runtime in order to execute that language statement. And in an era when everything had to be compiled, not any silly stuff like that, that was one of the prime examples that really got to us, that holy cow, they designed this in such a way that the only way to execute this is you have to go off on the side. You can't compile code for it. So and there were a number of examples like that. It was overly general. That would, I guess, what I would say. And it made me, when I started doing programming language design on my own, I was very, very careful that you don't throw the kitchen sink in there. You have every feature has to pay its way and has to be really good. An example, PL1 didn't have this, but Mesa did. One of the things we put in Mesa was exception handling, because it was always a horrible thing to do. And everybody in BCPL, you return a function, what should have been a procedure became a function. And if it returned -1, it meant that there was some error. And then you were supposed to do something about that. And we tried to do an exception handling mechanism where you could raise an exception and it would find a handler back up the stack, if you will, someone who said, I'm willing to handle that exception. And we made them resumable. That meant you could do something to fix something, like maybe set a lock or something, and then resume from where it had been. That was a bad idea. Now I'm forgetting. When C++ was being standardized, I was involved in that as well. And Bjarne and I had all kinds of arguments about this, but I said, don't do resumable. You need exception handling, but don't do resumable exceptions. They never paid their way in Mesa. And they made things, when you have to write the language manual and it is really complicated to describe this, it's a bad feature. I lost that fight to Microsoft, actually, and C++ ended up having resumable exceptions, and I bet they're hardly used.
Okay, thanks. I'm just thinking from the point of view of a user coming from Fortran and COBOL and assembler in IBM, I found PL1 was a dream language to write.
Oh, if you stayed in the, if you wrote in the right subset of PL1, it was just fine.
Yeah, most of the stuff that came out of Winchester, I don't know when it went to Winchester, but it came to Winchester in England at some point. They took it over, and I just thought it was, well, my favourite language of all time for writing it.
Goodness.
Well, my favourite was Modular 2, so I'm
the
right company, I guess.
But I guess I'm
not sure I have a favorite anymore. I probably. Yeah. No.
Right.
These days, my best programming is done in spreadsheets.
Yeah.
It might cause gasps of horror, but really Python's my favorite these days.
Python's everybody's favorite.
Yeah.
And it's, yeah.
Jim, can I ask a question about favorites then? Of all those that the achievements that you've listed, including the ARX ones, which is your favourite?
Of all the
Of all of your
things I've done,
yeah, of all your personal achievements and your personal and projects, which one would you say is the favourite?
Java.
Yeah, I bet. Yeah.
Definitely Java. Java was fun in many ways. One of the things I did there that I was most proud of, and it's partly, I mean, I love Java, the language as well. It did, I think, did a lot of things right, but was that we had this mantra of trying to make it so you could write your code once and it would run on anybody's system, whether it was Windows or Mac OS or whatever. And the sobriquet was, write once, run anywhere. And we were trying to make that true. And so, Java would make a layer on top of the operating system for the normal graphics and Windows and files and that kind of stuff. Well, as it became popular, the very next thing that happened was that the database companies, they were going to do their own, usually we called it JDBC, but so it was the SQL access to databases, and Oracle and Microsoft and Apple all wanted theirs to be favored. And we came up with this idea. We said, okay, tell you what, you bring some of your technical people together, we'll form a group, and they will define what the Java interface for SQL will be. And we came up with a social mechanism for that I really liked. The deal was, you form a team to do it. They are responsible for producing a spec, a test suite, and a sample implementation. The sample implementation didn't have to perform well, but it had to pass the tests, right? And when you had done all of that, we would publish it and say, this is now the official Java way of doing SQL. And then the team would have a party and they go back to their companies. No long-term committee or anything like that. Because the first rule of survival of any group is the first rule for any group that lives is surviving. Well, you want to get rid of that problem because standards bodies have this problem all the time. That worked out so well, we made it a standard thing to do. And by, let's see, in about 4 years, we had done 50 such interfaces for not just databases, obviously, databases and electronic funds work and all kinds of things. And first of all, technically, having the spec isn't good enough by itself. Having a test suite to test that your implementation meets the spec, and having implementation that we know meets the spec because it satisfies all the tests. That's good on the technical side and tends to make things that work out of the box. Whereas, most standards bodies, I don't know if you're aware of this, you don't have to implement the whole standard. You can implement any old subset you want. So in the early days of networking, the reason they would have these network conferences is because people would say, I got Ethernet. They wouldn't work together, right? So it worked very well from that point of view, and it was fast. As I say, we did about 50 in about 4 years, during which time in the global standards bodies, they might have done 2 or 3 things like that. And that's not even it's not per se a technical thing. I didn't build software or something for that, but all my background in software and being involved, I was involved in trying to do proofs of correctness of software. I was involved in the Euclid project at one point. All that fed into that, and it ended up making a mechanism that has worked very, very well. I wish standards bodies would adopt something like this. I'm actually most proud of that one thing that I did in in Java more than almost any technical thing. And the last thing, I haven't had one career. I've had about 6. And the last thing I was involved in was silicon photonics, and packaging at the microelectronics level is a big deal there, because if you're going to be talking chip to chip with optics, you have to have ways of aligning things very precisely and packaging them and so on. And that was probably the most fun I've had doing that work. But really, what came to be called the Java community process for building these interfaces that would then be adopted widely, that was probably one of the more successful things that I've done.
Well, that sounds like a really excellent place to wrap up then, I think, on a big successful note. So thank you very much, Jim, for coming along and talking to us.
Thank you.
Answering lots
Hey,
of
Joe,
questions.
thanks for being a good extra memory.
Pleasure.
Yes. Thanks to Joe and to Brian for his answers in the chat as well.
Yeah, and Brian, thank you.
Hey, Brian.
So then I see lots of rounds of applause going on.
Very great. Thank you.
Thank you all. It was kind of funny going back through this, and fun to go back and try to remember this stuff. I'm sorry that my memory's not perfect, but thankfully Joe and Brian were here.
Thank you.
And for those of you in the pub, have a good time.
We will.
Okay. And I guess we're bye-bye for now.
Yes, thank you. Bye.